The objective of this tutorial is to sketch the graph of the modulus function y equals f of x, and this is found in the book on page 64. The modulus of a number a, written in this form, a between two dashes, is its positive numerical value, which means that the modulus of a number a, written in that form as we have said before, is equal to the positive numerical value of this number a. Now, what is a modulus? The modulus of a number is its distance from 0, which means that the modulus to any number is its distance away from 0. Let's consider the following number line. This is the 0, which is the basic point in the number line. Before the 0, we have the negative, and after the 0, we have the positive numbers. Now let's take minus 1. How far is it from the 0? It's far away from 0 by one number. Also, plus 1. How far is it from 0? It's far away by one number too. That's why we say that the modulus of minus 1 is equal to 1. Again, if we take plus 5, how far is it away from 0? It's far away by 1, 2, 3, 4, and 5. Also minus 5, how far is it away from 0? It's the same, by 1, 2, 3, 4, and 5. So, minus 5 and plus 5 are away from 0 by 5 points. That's why the modulus of minus 5 is equal to 5. So, for example, the modulus of 5 is equal to 5, and also that of minus 5 is equal to 5 too. It is sometimes known as the absolute value. That is, we also call it absolute value, and is shown on the display of some calculators, as for example, absolute value of minus 5, ABS means absolute, or absolute open brackets minus 5. If your calculator has a modulus or absolute value button, make sure you understand how to use it. For example, this is the calculator. We want to determine the absolute value of minus 5. So we press this button of the absolute, then we press minus 5 and equal. It gives the answer 0. Also, let's try the absolute of 5, which is equal also to 5. So by this we learned that only by pressing on the absolute value button and add the number I want, it directly gives the answer. A modulus function is in general a function of the type y equals f of x. Now we have two cases. When f of x is greater than or equal to 0, which means that f of x is positive, the modulus of f of x is equal to f of x. In other words, if f of x is positive, the absolute value of it is itself, which means the same number. The second case, when f of x is less than 0, this means that if f of x is negative, in this case, the modulus of f of x is equal to minus f of x. Why? Because, as we have said before in the first part, that the modulus of f of x is equals to f of x. But here, f of x is negative, so the modulus will be negative. And since we have said that the modulus is always positive value, so the modulus of f of x is equal to minus f of x. Since f of x has a negative sign, so minus times minus equals plus. And by this, the modulus is positive again. So let's repeat. The modulus of the function has two cases. If f of x is positive, the modulus will stay the same like f of x. But if it's negative, the modulus of f of x is equal to minus f of x. Now, let's look at this example to learn how to sketch the graph of the modulus function. Since the equation is y equal absolute value of x, so the values of x and y are the same or equal. Let's consider the values of x and y from -3 to +3. You are free to choose any number you want. Here we chose from -3 to +3. We will take the points and plot them on the coordinate plane to see how the graph of the equation will be or look like. Now let's plot the points on the coordinate plane. Now let's start with the first point, which is -2, -2, and this is the first point. The second point, -1, -1, here is the second point. The third is 0, 0, which is the origin. Then 1, 1, and this is the fourth point. And the last point is 2, 2. 2 on the x-axis and 2 on the y-axis. Now let's connect the points together to form the graph of the equation y equal modulus of x. So this is the graph of the equation y equal modulus of x. Now we are going to learn how to determine the graph of equation y equal modulus of x.